Consider this structure: CH3, CH2, CH2, 2, CH2, OH. How would you draw the Kekule structure of this condensed structure? Now, Kekule structure is the same as a Lewis structure, except that you don't have to draw all of the lone pairs. So if we want to start doing this, we would first begin with the CH3. So we draw a carbon, and it has 3 hydrogens attached to it. So start from the left. And then we have a CH2, which means a carbon with 2 hydrogens. And then always leave a space to the right open so that you can attach the next thing to it. And carbon always has 4 bonds. So we have CH2s and we have 2 of them. So you have one CH2 and then you have another CH2. And then we have another CH2 at the end. And that CH2 is attached to something called an OH, which is a hydroxyl group. So an OH will look like this. And oftentimes people don't draw the bond between the oxygen and the hydrogen. They just put an OH. Try this example. CH3, CH2, CH, Cl, CH, CH3, 2. So once again, we start on the left with a CH3. And then we have a CH2. So we draw the carbon with 2 hydrogens attached to it. And then we have a CH. And then we have a Cl. That Cl is going to go on the same carbon. So a Cl is basically a chlorine. And then we have a CH. And that same carbon is attached to 2 other things. So it's attached to 2 methyl groups. So CH3 is methyl. So whenever you see methyl, it's usually going to be at the end of the chain. So it's not going to be in the middle. So now this next example, we have CH3, CH, CH3, CH, OH, CH, Br2. So we have a CH3 at the left side, starting from there. We have a CH, so that's carbon, hydrogen. And it looks like we have a CH3 in the middle. So what do we do in that case? Well, we don't go like this and then attach all the rest of the stuff to it, because then the carbon would have 5 bonds, which is not what happens, because if you expand this, I just erased 3 hydrogens, so it would have 1, 2, 3, 4, 5 bonds. That can't happen. Hydrogen or carbon usually has 4 bonds. So instead of doing that, the CH3 goes on to the side. And then whatever comes after attaches to the right side of the carbon. So we have a CH. And then we have an OH on the same carbon. And then we have another CH, which has 2 bromines attached to it. So that's how we draw the structure for that condensed structure. Now, let's go over one more example. CH3, C, CH3, 2, and then CHF, CH2, CI3. How would we do it for this one? So again, we started the CH3 on the left side. And then we have a carbon that has 2 methyl groups attached to it. So the CH3 is a methyl group, and it has 2 of them. And we said that when you have a methyl group in the middle, you put it off to the side. So this would be the main chain, and then you'd put it off to the side here. And then we have a CH, and we have a F, which is fluorine. Then we have a CH2, so a carbon with the 2 hydrogens, and then we have C, but it has 3 I's attached to it. The I's are iodines, so that's how we draw this one. So that's it for this video. There's a part 2 to this video that goes over more complicated examples, so feel free to watch that if you want. But this should give you a good introduction into drawing these structures for organic chemistry.